So in the last video, we tested out our character and our battery blueprint by creating a blueprint to spawn just one battery in the world. Now we'll set up a spawning volume in code and set up variables and functions to tell the spawning volume what, where, and when to spawn. We'll go ahead and start adding our code class with the add code to project wizard. We're going to place these spawning volumes within our level, but other than that, we don't need any particular functionality, so we can inherit from actor. Select actor as your parent and go ahead and name this spawn volume. Create the class and it'll load up either in Visual Studio or Xcode if you're on the Mac when you edit the code. You could also go ahead and close the editor once Visual Studio or Xcode is loaded, because we're going to be in writing code for basically the rest of this video. So we'll set up our box component first. When we add an instance of our spawn volume to the level, we can transform the box component to specify the volume we want the pickups to spawn in. We're going to use the same syntax we've used when setting up our other code components with the T subobject pointer, and we'll name this where to spawn. We're only really going to want to change these once we've placed the spawn volume actor within the level. So we'll make this component visible instance only and put it in the spawning category. Go ahead and zoom in a little bit here so you can see. Now we'll start declaring our spawn volumes variables. First, we're going to have the what to spawn variable. Using the T subclass of syntax means that we can tell our spawning volume to create instances of any class based on our starting pickup class. So T subclass of class A pickup, and we'll call this variable what to spawn. We'll make this a uProperty that is edit anywhere so that we can set either within the code class or within each individual instance, and we'll also put that in the spawning category. Now we're going to create functions to pick a random point to spawn at and also pick a random delay before spawning the next pickup. Our box component is used to set the minimum and maximum spawn locations, but let's set up two variables to set our minimum and maximum spawn delays now. We'll call these spawn delay range low and spawn delay range high. If you notice, these both have the same uProperty specifiers, so they're both edit anywhere, blueprint read write in case we ever do make a blueprint down the road that extends this spawn volume class. And I have just put all of these within the class constructor. So let me just grab those real quick, switch over to my header file, and put them here in the class declaration. I'll clean that up a little bit. So yes, always make sure that you're in your header file when declaring variables and your source file, the one that ends with .cpp, when you're actually setting values or definitions. So we've set our spawn delay range low and our spawn delay range high, or basically told our spawn volume that we're going to set those at some point. Finally, we're going to create a get random point in volume function. This function will pick a random location within our box component. Now, if you see here, I've marked it in our ufunction macro as blueprint pure. If I wanted to extend this spawn volume with the blueprint later on, this would make a get random point in volume node that I could use to pick a random point for some other functionality, like spawning particle systems or maybe teleporting the character around. Again, these are all in the spawning category so that I can find them later on. Up until this point, we've mostly been working with public variables and functions. By default, all variables and functions added to the classes in Unreal Engine are public, so they can be accessed by other classes within your game module. And that's actually part of what this generated uClass body right here, that actually part of this macro is setting all of these below it as public. However, I'm about to set up some functions and variables that I only want my spawn volume to be able to access, so I'll mark them as private. And to do that, you just type private in here, and then anything below this will be accessible only by the spawn volume class. So we will have a function to pick a random spawn delay and a variable to store the current spawn delay. So the get random spawn delay function will return a float, and that will actually be stored in the spawn delay float variable. we'll also have a function to handle spawning the pickup. Basically the whole purpose of this class. Which will handle the spawning of our pickup, and void spawn pickup is this function. So now let's switch to the source file and set up values for our variables and definitions for our functions. Also, we are using the aPickup class here. So in our source file, one of the first things we need to do is add an include for our pickups header file. So now that we're in our class constructor, which I had before, let's set up our box component and make it the root component. Again, this is pretty straightforward, pretty much like when we set up our pickups earlier. We make where to spawn with the create default subobject helper, and we'll make that the root component. Now we'll set the spawn delay range and get the first spawn delay. So just spawn delay range low is 1, spawn delay range 5, spawn delay range high is 4.5, and then when the spawn volume is first added to the level, we'll go ahead and get our first random spawn delay. Now, because we made these variables edit anywhere, we can override them either on individual spawn volume actors once we add them to the level, or if we did extend our spawn volume with a blueprint later on, we could override them there too. So that's the basic behavior for each new spawn volume actor. Now we'll define the function that actually spawns our pickups. I'm going to copy and paste the code I've already written here and then basically walk through each section so you can follow along. So this is the spawn pickup function. We'll zoom in even more here. So first we really want to check that we have set a pickup to spawn. So if what to spawn is not null, then we can keep going and try to spawn the pickup. Another safety check that we need to do is whether or not we're actually playing the game and if there's a valid world. So we have this uWorld equal to getWorld. So if that exists, then we can actually start to spawn the pickup. We have an owner of the pickup and an instigator, and those are just going to be set sort of default. You know, this spawn volume is owning the spawned object. Next, we'll get our random location to spawn at, and we'll set up this getRandomPointInVolume function in a little bit. Next, we're going to get the spawn rotation, which is really getting a random value and setting it for our yaw, pitch, and roll. Finally, we'll use the spawn actor function from world to spawn the pickup. And as you can see, this is why we actually needed to check that world is valid, because we have to call the spawn actor function from within the uWorld class. And we just feed it the spawn location, the spawn rotation, and those instigator and owner parameters we set up at the start. So just a little bit of code there, but really the important parts are to check for we actually set something to spawn, and to check that we're playing the game and a world does exist. And then, if you were adapting this for your own game later on, you could set a different location rule or a different way to find the rotation, as long as you did specify a location and a rotation. Now we're going to set up our functions to pick the random spawn delay and the random spawn location. The random spawn delay is actually really straightforward. So the getRandomSpawnDelay actually just returns a float in the range between our low value and our high value. So there's already this fRandRange function in the fmath class that is already set up for you, and will pick a random float in the range. The random spawn location has a bit more math involved, and so as we go through this, hopefully you can see why I marked this as blueprint pure. It has some useful functionality we wouldn't necessarily want to have to duplicate in a blueprint graph each time. So wrapping it up in a function and then making that accessible in blueprints means that we could use those, basically use that later on. So again, I'll just copy in my function and then walk through each step. this returns a vector, an F vector of random location. So first we get the spawn volumes, origin, and box extent. That's just something that's wrapped up within the box component, origin being the center of the box, and then the box extent being sort of the size of the box within the level. Next, we'll calculate the minimum x, y, and z by subtracting off half of that box extent from the origin, so everything would be shifted to the minimum. And then next, we will calculate the maximum location by adding on to that origin location. And then again, we use this fmath fRandRange function to pick a random x, y, and z, each between the minimum and maximum x, y, and z. Finally, we just return that, and so we'll have a random x, y, and z coordinate within the spawn volume, because we're using where to spawn to give us our origin and box extent. Now at this point, our spawn volume could be added to the level, but if you notice, we didn't tell you yet when to call spawn pickup. So in the next video, I'll show you how to set up the spawning behavior, and then we can add a spawn volume actor to our level.